one slice or two. So today I'm just going to pull this toaster apart. It kind of works, but the reason it looks so grubby, by the way, isn't because my kitchen is totally disgusting, though it's not always the best, I have to be honest. It's actually because it's been sat outside, having been thrown out the back door. So well, the problem with this toaster, the main problem is it's got these bits inside that lift the bread up and down when you use the leaves on the front, and they're really flimsy and they bend, and I finally got sick and tired of trying to bend them back. I did consider opening this up and seeing if I could strengthen it, but in the end I had enough and I just bought a new one, which I know is not really always the right thing to do, but these manufacturers seem to like to design things to break. So the other thing that's interesting with this is it's clearly not designed for maintenance, because they haven't even bothered to put screws in. They've just used the metal housing and twisted it around. Now, I've seen this in the iron I took apart on a previous video, and you just basically twist the metal back and then it's supposed to fit back through the slit in the plastic work to get inside it. Well, I don't think you're actually supposed to get inside it, to be honest. And then there's all these tabs along this edge as well, so just push these back. There's quite a few actually, but then I suppose there'd need to be because it's quite flimsy metal. And there's some more along here. And another one in the middle. Let's see if we can get this off now. So it's lifted at the front a little bit, so I'll see if I can ease the rest of it off by going round. By ease, what I mean is use a screwdriver as a crowbar. Now, there may be some more underneath these little trays. See? I do clean it. Ah. Wow. I didn't expect to see any of those on here. Some screws. So it looks like this may have to slide off in some way, but I don't really know how it would slide, unless it just needs to lift. I'm a bit wary because of it being sharp. Alternatively, I could just lever it. I'm not sure with this. Maybe these need to be bent upwards. Yeah. So they're just tabs. It's not. I thought the whole back piece was perhaps bent over, but then thinking about it, because this has got a bit of a curve to it, it wouldn't make sense for it to be like that. So these are just tabs, so they just need bending up. I'm surprised they put any screws in, to be honest, unless there's some legal thing with mains appliances to have at least one screw or something. I don't know. Who knows? There we go. It's going to make a right mess on my bench. So I've also got to probably pull these off somehow, I'm guessing. I don't know if they just pull off or how they... We'll soon find out. Yeah, they look to be... Yeah, they're just push fit. the knobs are not actually, oh, they're on a separate PCB, so we've got 2 PCBs. So really, with this being a 4-slice toaster, what you've actually got in effect is two toasters in one. It's just two doubles, so each pair operates as one unit, and the metalwork on this is just so flimsy, it's unbelievable. And this is a problem with trying to repair something like this. The damage that you can end up doing just getting into it, by the time you've sorted the problem out, you might not get it back together again in one piece. And again, this is all little tabs that are bent over. If you can perhaps see those. I think there's one left. So it's just a tab that needs to be straightened out, and then that part of the metalwork can be popped over. I think what I'm going to do is just chop these wires. I mean, you can't see them, sorry. So what I'm going to do is just chop all these wires here, just so I can get this out of the way, and then we can have a bit better look at it. Not all of these appear to be mains wires. Some of these are clearly got a heat-proof coating on, or heat-proof sleeving of some sort. Just chop that, just makes life a bit easier, and then we'll come back to this piece and have a look at these PCBs. Lovely bits of crusty bread from the past 7 years, probably, I think. Nice. Yeah, so these are some kind of contacts, and that's partially activated by this larger mechanism being pulled down, and then that looks like that's supposed to then latch somehow. You can see that latches in there. I think because there's no power applied to this, normally when you pull that down it will latch. You can see in here something that looks a little bit like a transformer. That would be some kind of solenoid, I think. So that would get energised, and this piece of plastic here has actually got a piece of metal on the bottom. So once this is down like that, that gets energised, and that will pull this in that position. So when I then let go of the handle, it stays latched. So your toast is then down in the toaster, and that will stay latched until whatever triggers the toaster to release the toast. So then this solenoid thing down here will be de-energized, so it will lose its magnetism. The metal plate on here won't be attracted, and then it will just release, and then your toast pops up, which is just, you've got a spring here to pull the toast back up, and then this spring looks like it's some kind of a dampener, so this doesn't just slam straight up into the case. So it's a little bit more of a gentle. And most of this is just mechanical. You can see here this wire here just pulls these outer bits in at the top there, and that's what activates these. I suppose they're like a little gate thing that hold the bread as near to the centre of the toaster as possible. And obviously you should be able to, you may be able to see down there the elements. And obviously it's just duplicated on the other side. Looks like these are the feeds to the actual elements, and yeah, there's another one the other side there, and on the back we've got some feeds as well. So yeah, these wires are all just to feed the actual heating elements to cook the bread or burn the bread, whatever you do. And this mechanism is just ultimately just a very cheap and crude switch to switch the elements in. And that's what these little wires here that are not the thicker mains, these are all going to be probably mains carrying cable. These are just probably a lower voltage to activate this little solenoid thing down here. We may actually be able to power that up. Unfortunately, I've cut the wire a little bit short, but we may be able to power that up out of interest. So as you can hopefully see here, I've stripped these ends off of this wire to this little solenoid thing here. I assume technically it's a solenoid, but I'm not 100% sure because it's not firing a pin out. It's a static thing itself. It's just attracting something to it. So I don't know if technically it's a solenoid or not, but I've got a 5 volt supply. I don't know what power rating this is, so it might go up in smoke, but it won't be the first time this toaster's seen fire, that's for sure. So I'm just going to energise that, so nothing really happens. But if we push this down and let go, you'll see it springs back up. However, if we apply power, then push it down as if we were putting our toast in and pulling this big lever down. So if we push it down by hand on its own first, you'll see it now stays latched, and that would keep these contacts closed, so then the elements would be activated and burning your toast or burning your bread. And obviously that would also keep this larger mechanism in place, and then as soon as the toaster's decided that the toast has been done enough, it will de-energise that and it pops back up. Now these are the troublesome parts here, these bits that go into the toaster there, so I'm just going to see if I can pull one of these out, and again it's just bent over bits of metal, so it's no wonder it fails. And there's no real support at the back here. There's not like 2 pieces front and back pulling the toast up. It's all the pressure is at one end, so it's going to force it to bend down like that. Let's see if we can get this out. How they would have actually got that in the first place? They probably would have bent these ends over last as well. That's a bit of a guess. Yeah, so this is the problem. This entire thing is holding your bread, and as you can see, it's very easy to bend. I mean, it's just buckled again. Obviously this has been bent a few times before, but that's the problem. They use such a poor bit of metal to do that. Why not make this particular bit out of some much thicker metal, and then the toaster will last a lot longer? It's such a shame, but that's how everything is. There's not really a lot else to see here. It's just a metal mechanism, really, more mechanical than anything on this side of things. I'll probably just strip all the metal off and then chuck that for scrap instead of all the plastic going with it. It's just, again, it's lots of metal tabs holding it down to a base, so no screws. It's all just very cheap, nasty construction, really. I found these points here quite interesting because they've obviously put these tabs on the end of the cables, these little crimp things, but then they're actually spot welded onto the casing. They're not screwed, they're not little push fit lugs, they're just spot welded on. Again, it's probably cheaper and quicker to produce that way. It's very, very sharp, some of this. It'd be extremely easy to slice your fingers up on it. So we can have a bit of a closer look at this now. As I say, you can see it's just activating different contacts. There's another contact here. I think that's probably activated by the larger mechanism, so there's probably a combination of things that need to happen for the heating elements to be triggered. Probably a safety thing as well, so if the thing's not down, it won't activate. I don't know if I can get that out of there without breaking this. You may be able to see here there's a bit that looks darker. That's actually the metal plate that's magnetic, and that's what gets attracted to the top of this coil. So you've just got a coil with a piece of iron core or ferrite type stuff through it, I think, and that just gets attracted to that. It's not attracted enough that it can pull it down, but when it's already down and then it's magnetised, then it will hold. This is one of those situations where I could really do with another light over this side to just light things a bit better here, so that's something I might have to consider experimenting with. The only downside is it can often cast more shadows, which is even worse at times. And just a strain relief on the mains cable, which is not particularly long really. So these clips here are obviously the ones that hold the actual mechanical part of the toasting mechanism in place. They're not for the casing, because obviously I've already got the casing off. The casing was the outer metal clips, or tabs. I suppose they're more tabs than clips really. So really that should pull off, but yeah, there we go. I'm just a little bit wary because, as I say, this is extremely sharp in places. So a good tip for dealing with these irritating twisty tab things, if you can't pull the thing off, is actually just get the pliers on it just near the end, nip it tight and then push it, and then you can push it through, and then that will release that a bit more. There's another one here in the middle that's a bit mangled. So see if we can release that with it, preferably without releasing any blood out of my fingers. Lovely. Oh, I don't know about hoovering in here when I've done, but I think maybe even disinfecting the place is absolutely awful. So that's the toasting mechanism, I guess. Now somewhere in here there's these elements. I don't know if we'd be able to get those out really. You can see we've literally obviously designed the product as two separate parts, and it'd be very likely that there's a single, there probably was well, not a single, a double slice version, 2-slice toaster, and it's probably exactly the same mechanism that do that, obviously to reduce design costs and things. And then all they're doing is just bolting the two together with some extra metal work for the 4-slice version, which makes perfect sense really. There we go. And then we've got the actual elements in here on these boards. Let's see if we can free these from their prison. Again, a tab, a couple of tabs, and then I should be able to just, if we move those out of the way, then that means that part there is the board, and that can then be pushed and then probably pushed down that way towards what would be the top of the toaster to free these boards. Turn that out of the way altogether. So really that should be possible to remove that now. This wire on the end here might be a problem. There'll be one. There'll actually be another one lower down. Sorry if this isn't showing very well on the camera, but and that's it. That's the thing that makes your toast. So this is going to be some very heat resistant material of some sort. I don't know what it will be. And you can see they've put thin strips of that which is riveted together, and that just holds this wire into place. They've skipped various bits. They may do that because the length of this is probably going to have a different resistance, and then they'll use different lengths to get different temperatures on different voltages. I'm guessing, I don't really 100% know. But yeah, so there'll be a few of those in here. I don't know if the centre one, this one's probably double-sided. You see on this one here, what they're doing is they're going across and then they're just looping round this small area here at the back and then going back round again. Whereas this centre one, they're going to be a bit more clever and they're going to have a longer run, or maybe not a longer run actually. Looking at it, it might be the same length of wire, or whatever this stuff is, it's some kind of wire, this heating element, but they're going to run it both sides. So if we'll get the middle one out and have a look at that, because I think that'll be quite interesting to look at. Again, it's all horrible metal tabs. Doing any maintenance on something like this to try and repair it would just be a nightmare. As much as I don't like the waste that we have with things like this, when a lot of the time things could just be so easily repaired, or more to the point, built properly in the first place so you don't have to bloody repair them. It's just not worth it with things like this, unfortunately. Yeah, so you can see there's almost twice as many runs of wires on this one on this side. Not quite, but almost. Yeah, this one, there's probably the same length of wire in total, but they've just run it around both sides. And I've got two of these retaining strips, one either side, whereas here we've only just got it at the one side where we need it. So obviously it's more efficient because that can then heat both sides. Well, two separate sides of two separate slices of bread at the same time. So I'm not going to tear any more of this down on the camera, if I tear any more of it down at all. It's just going to be a repeat of this. We're just going to have the two-sided one in here and then a single-sided for either of the outer sides of the toasting unit. And I'm going to wipe some of this crap off the desk because it's not very nice. So that's the main part of the toaster dispatched with. Again, it's a similar situation. We've got two sets of controls because it's effectively two toasters in one. That's basically what we've done here. We've got some clips here that I can see. I assume that I'll then be able to pull that over there somehow. Oh, we've actually got some screws on this. I didn't notice those. Let's see if I can make that a bit easier to see. So yeah, we've got these 4 screws on here on this PCB. And blocking you a bit again. So I would expect that there's going to be some kind of microcontroller of some sort on here. Whether we'll be able to tell what it is, I don't know. I probably won't, because I probably won't recognise the chip, but somebody out there may. And they may be able to tell us what it is. HT48R06. Not quite sure what that logo is, but then we've just got the standard cheapo dome switches that you get in everything. So you got your cancel button, your bagel button with its bagel light, the reheat button with a reheat light, or they've called it warm there, and then a frozen button with its frozen light, or LED. And then we've just got a variable resistor in the middle, which is what's used for the adjustment. So that probably just alters the timing that it allows for the bread to be toasted. And again, that's what these buttons here will do. So the frozen button, I think what it does is just increase the time. I don't think it adjusts the temperature, but I could be wrong. It may pulse the heating elements on the boards next to the bread, rather than just have them on full. I don't really know how it works, to be honest, although it doesn't look like there's anything on here that would be capable of switching in that manner. So if anyone's got any idea how this might actually work based on this board and obviously the wiring that you can see, this little 2-core wire here is obviously for the solenoid. This is obviously, I'm going to say this is the AC feed, but I'm not really sure about the other 3. Probably should have looked a bit more before I pulled it all apart, but yeah, it doesn't really matter. So that's it. That's the last slice for this toaster.